Human children can learn words through a process of fast mapping, with minimal experience, as simple as being shown a novel object and hearing, "This is a blanket." Toddlers can learn a new word. Fast mapping can also take place when two objects are shown, one that is known and one that is novel, and an experimenter asks, "Which one is the blanket?" With this minimal experience, children learn not only the association between a new sound and a new object, but they are able to understand and use it in new sentences. That is, they learn a word. Fast mapping is typically considered to be an integral aspect of language development. Thus, the attention of many was piqued when researchers suggested that Rico learned words via fast mapping. Rico was able to choose a novel item among familiar items when told to fetch novel word. That is, when presented with a novel word, he ignored known objects and returned with the novel one. Weeks later, there was evidence that Rico remembered these new word-object pairings. Although Rico's learning is undeniably impressive, concerns were presented regarding the claim that Rico had learned words by fast mapping. For instance, it is unclear from this study whether Rico learned that the novel word referred to the object itself, or whether the sound was encoded as part of a command to fetch. The former would allow for understanding of the word in other contexts that do not involve fetching. As Bloom 2004 notes, children appreciate that a word, e.g. sock, can refer to a category and thereby be used to request a sock or point out a sock or comment on the absence of one. In a study inspired by research with Rico and the subsequent commentary, another border collie, Chaser, was trained by her owner to respond to over 1,000 words, and then specific aspects of Bloom's concerns were examined. For example, because Chaser was able to produce appropriate behavior when 3 different commands were randomly paired with 3 different objects, Pilley and Reed suggested that Chaser understood the names independent of the behavior directed toward the object, e.g. understood sock, rather than as a command to fetch sock. Still, important differences exist between the way dogs and children learn words. Children learn words from overheard speech and can use words outside of contexts in which actions are performed on objects, and learn words for concepts such as love or happiness. Although the work with Rico and Chaser is challenging the way researchers think of word learning, there is still good reason to think that children understand reference in a different way, and it is the task of the fields of comparative cognition and developmental psychology to formulate exactly what these differences are. Conclusions. Even if the most parsimonious interpretation of the ape language studies is that the individuals tested were basing responses on learned associations, as previous chapters of this book have noted, this learning mechanism can lead to representations of the world that affect behavior. The underlying cognitive processes may still be quite complex, even if they do not completely overlap with the processes that allow human language development. Arguably, though, the study of natural communication systems has increased our understanding of cognition and evolution as much, if not more than, studies aimed at directly teaching language to animals. Again, further research is required to fully understand the nature of the representations that are generated from, for example, alarm calls or food calls, or even how one signal might influence the interpretation of subsequent ones, as may occur with play signals. Existing theory has been developed from research that effectively combined observations of behavior in the wild with field and laboratory experiments, and further work using this comparative approach will bring us closer to understanding the cognitive processes of communication and, at an ultimate level, the evolution of communication and human language. Chapter Summary. The topic of communication encompasses a broad range of behaviors, transmission across varying media, and perception via different sensory modalities. The transmission of information between individuals occurs through communicative signals produced by a sender to a receiver. Signals can be active, such as alarm calls, or passive, like the coloration of poisonous tree frogs. Human communication is characterized by an unlimited signal set, but it is thought that most animals have a relatively limited signal set. If the signals provide information specific to a particular object or event and are not simply signals that convey, say, generalized arousal, and if the receivers of the signal respond to the signal even in the absence of the stimulus that elicited it, the signal is considered to be functionally referential. These signals provide receivers with sufficient information to predict events in the environment when the receivers cannot directly perceive the event themselves. Signals are not necessarily truthful indicators of the quality of the sender, but can benefit the sender by manipulating the receiver. In some cases, though, the nature of a signal would suggest that it is too costly to fake or simply could not be faked, and thus honest signals can evolve. Von Frisch carefully detailed the behavior of bees when they returned to the hive after finding nectar at faraway locations. On the vertical side of the honeycomb, returning bees performed a waggle dance. Different elements of the dance appear to contain information relevant to the distance and direction of the food source. There is evidence of functional reference. However, the reference appears to be a location, as dances can recruit observers to visit food sites or even potential nest sites. The relatively limited signal set that characterizes most animal communication includes calls that are elicited by predators and food sources. Vervet monkeys, for example, give 3 different sounding alarm calls to 3 types of predator: leopards, snakes, and eagles. Playback experiments suggest that these calls are functionally referential. Calls made in association with food have been reported for many primate and bird species. Some of the strongest evidence for functional reference in food calls comes from chickens. After discovering food in the presence of a hen, roosters emit a specific vocalization that has an acoustically distinct structure. When these calls are played back to hens, they look to the ground as if searching for food. It is commonly thought that play provides training in physical and social skills that are needed for survival and reproduction as an adult. Play markers, specific and highly stereotyped behaviors, like the bowing motion of many canids, can serve to initiate and maintain the play context. In the second half of the 1900s, there was a series of attempts to teach human language to great apes. The studies also played an important role in stimulating research and new methodology in the study of language development in children, which in turn pointed to the differences between the language-trained apes and children. Existing theory has been developed from research that effectively combined observations of behavior in the wild with field and laboratory experiments, and further work using this comparative approach will bring us closer to understanding the cognitive processes of communication and, at an ultimate level, the evolution of communication and human language.